Here's another good problem for you. A student collects 425 milliliters of oxygen at a temperature of 24 degrees Celsius and a pressure of 123 kilopascals. How many moles of oxygen did the student collect? All right, so I have gas under one set of conditions, nothing's changing, and I'm just trying to figure out something about it. In this case, it's moles of oxygen. So that screams PV equals nRT, the ideal gas law. And we're trying to find number of moles, so I'm going to divide both sides by RT. So I'm going to say N equals PV over RT. And remember that I like to do R either first or last. So R is 0.0821 liters times atmospheres over moles times Kelvin. But if you're in the denominator of a denominator, you flip up to the top. So it's moles times Kelvin on the top. Then the pressure is 123 kPa. And the volume is 425 milliliters. And the temperature is 24 degrees Celsius, which in Kelvin is 297.15 Kelvin. All right. So if you're somebody who's not real careful about units, you are somebody who's going to get this problem wrong. Let's take a look at what I mean. All right. I am going to cancel all the units I can cancel. Here's Kelvin, here's Kelvin. After that, nothing. That's the problem here. My units are all messed up. So I can just add, this is multiplication and division, right? So order doesn't really matter. So I can just add right onto here. So let's do the volume first. I need liters and milliliters. I need to convert this milliliters to liters, so it'll cancel with this liters. So 10 to the 3 milliliters in 1 liter. And then the other thing that I have to do, now that I've got all these things going bye-bye, is kPa in atmospheres. So you have to know your conversion between kPa and atmospheres, or look it up on the equation sheet. You get 101 point, sorry, Mr. Ryan. Put units down first. kPa goes down here, ATM goes up here, then fill in numbers. 1 atmosphere, 101.325 kPa. All right, now kPa is going to cancel, atmospheres is going to cancel, and finally I'm left with moles. And when you do all your calculations, you get 2.11 times 10 to the minus 2 moles oxygen. All right, so this is an example of a problem where there are lots of things going on, even though it seems fairly straightforward. So just be careful about the units.